चलिए यहाँ से start करते हैं. अच्छा, last time we just did as a next part we did body per second, we did questions. ठीक है, वो I sent you an assignment. ठीक है, try and do that. The next part is कि we started with solubility and enthalpy change of solution. उसके अंदर था कि enthalpy change of solution was that it's basically just dissolving a substance. So the amount of energy that is released or absorbed when you dissolve 1 mole of any substance, ठीक है, that's enthalpy change of solution. ठीक है, so NaCl dissolves, dissociates, ठीक है, mixes in water. Ethanol dissolves in water, forms an aqueous solution. ठीक है, so I told you that if enthalpy of solution is exothermic, that means what does that mean? It means that the substance is very soluble. That means you don't have to give it any energy. बाहर से कोई एनर्जी नहीं चाहिए, वो खुद ही सारा काम करेगा. ठीक है, it's more soluble at lower temperature. If it's endothermic, that means you need energy to dissolve it, and it is more likely to dissolve at a much higher temperature. ठीक है, so that was enthalpy change of solution. जो next definition है ना, that's what's the next one? The next one is hydration. ठीक है, that's the only one I think that's left. ठीक है, ये AS में किया होगा, लेकिन it's not in AS, and it's in A2, so this is the standard enthalpy change of hydration, specifically for gaseous, specifically for gaseous ions. So what is the standard enthalpy change of hydration of gaseous ions? What happens in this is that, simply speaking, it's you've got a definition per लिख लेता हूँ. It's the energy that's released. It's always exothermic. When what happens when you have 1 mole of gaseous ions, so when 1 mole of gaseous ions are completely surrounded by water molecules, they are completely surrounded by water molecules to form 1 mole of aqueous ions. Standard conditions measured under standard conditions. Yani simply ये कि you've got a gaseous ion, so it's an ion that's not bonded to anything. It's just a standalone. ठीक है, अकेला एक ion है. ठीक है, freely moving around. ठीक है, there's nothing attached to it, and all of a sudden it is dissolved in water. And when you dissolve it in water, what happens is that it gets completely surrounded by water molecules, and it becomes an aqueous ion. Okay, so it could be any ion. And visually speaking, what is going on is you've got aqueous means that there's lots of water molecules. Okay, so there are let's say there are let's say there are 3 water molecules. Okay, and there's this sodium ion that's gaseous, that's just freely moving around. When you dissolve ions in water, what usually happens is that the positive ion, it's an ion dipole attraction. The water molecules are, these water molecules they've got these lone pairs, and these lone pairs have a slight negative charge, which is why the water molecule gets attracted to the sodium ions. And they all get attracted to it. So the negative, so it's this one, the force of attraction that is formed That's an iron. That's an iron dipole
अबो
attraction. ठीक है. अच्छा, Saf, I think your mic is on.
20 টাকা
So,
লেট কেবল
just a second.
আর 20 টাকা টাকা লোন পর 10 টাকা থাকবো বললাম 20 টাকা
ठीक है. अच्छा, so that's it. Okay, you've got a gaseous ion. It forms bond with water molecules. It gets surrounded by water molecules. This is always what happens when you dissolve ions in water. The ions get surrounded by water molecules. Since this is bond formation, okay, only bond formation is happening. You're not breaking any bonds. Okay, you're only forming a bond. So this is why it's always exothermic. Okay, so it's always going to be exothermic. So that is simply enthalpy change of hydration of any ion. It could be Cl ions, it could be for some ions you don't have enthalpy change of hydration. For others, let me just do other examples. Like I've got Cl minus one aqueous, not aqueous, sorry, gaseous. Gaseous simply means that it's not bonded to anything. You mix it in water, and it will become aqueous. It will get completely surrounded by water molecules. Okay, that's it. Now, remember, enthalpy change of hydration is for only those ions that actually turn into aqueous ions. It's not for ions that don't actually turn into aqueous ions when you mix them in water. So for example, just note this down that that delta H hydration for oxide ions does not exist. Because the problem with oxide ions is that they don't actually get surrounded by water molecules. They actually end up reacting with water molecules. It doesn't exist. Why? As oxide ions react with water instead, and they actually end up forming new products. To form new products. So, for example, the oxide ions is if you've got gaseous oxide ions and you mix it in water, so instead of aqueous, I'm just going to write just a second. So I'm going to write water. अच्छा, इस केस पे क्या होगा कि it will actually turn into hydroxide ions. You're going to get, I think, 2 OH ions. Aqueous. Okay, so you can't call that enthalpy change of hydration because that's actually a reaction that's taking place. Okay, ये बात clear है? Is this clear that enthalpy change of hydration only exists for those ions that actually turn into aqueous ions? Some of the ions, they don't actually turn into aqueous ions. They actually react with water. ठीक है? ये clear है? This part?
Yes.
Yes, sir.
So that's it. Okay, so we did enthalpy change of solution, which is that you dissolve 1 mole of any substance in water, it turns into aqueous state. It turns into aqueous state. Energy is released or absorbed, so that's enthalpy change of solution. Enthalpy change of hydration is pretty similar, but that's only applicable to gaseous ions. You dissolve a gaseous ion in water, it turns into an aqueous ion. That's it. Okay, we did lattice energy previously. What was lattice energy? Lattice energy was that gaseous ions get together to form this solid ionic lattice. Okay, that's it. Now, these three are interlinked because, especially for dissolving ionic substances. So when you try to dissolve ionic compounds, there's a Hess cycle that can be constructed and only specifically for ionic compounds. That Hess cycle looks like this, that if I have NaCl solid and I try to dissolve it in water, what is going to happen is that that 1 mole of NaCl will dissolve and dissociate. Its ions are going to get completely scattered in water. Okay? So that's basically enthalpy change of solution. Okay, so 1 mole of any substance completely dissolves in water, and let me इसको ना पिक्चर के साथ शो कर देते हैं. Just 1 second. Just 1 second. अच्छा, यहाँ पे ना So this is what's happening, that the ions get scattered in water, they get completely surrounded by water molecules. And initially, the ions were all together forming an ionic lattice, which is, let's just take this one. So this is what happens when you dissolve an ionic lattice. You have ions that are strongly bonded to each other. And then all of a sudden, when you mix it in water, you stir vigorously. The ions, they all dissociate and they get scattered in water. And in water, they get completely surrounded by water molecules. So I think the plus one over here, पता नहीं, हाँ ठीक है, this is water, ठीक है, this is H, and this is, the red one is oxygen, ठीक है. So the white and red and white, they're basically water molecules. Now, when you dissolve something, ionic lattices, there are 2 steps involved. Okay, you have to stir vigorously. Why do you need to stir vigorously? Because you want to break the lattice. You want the ions to be scattered. So you get Na+1 gases, you break the ionic bonds, and you get Cl-1 gases. So the first part is कि जब आप NaCl लेते हो ना, salt, table salt, you stir vigorously, ठीक है? So you're just trying to break. So you're trying to break the lattice. So lattice energy was that gaseous ions would form 1 mole of ionic lattice. Now you're doing exactly the reverse. If you're doing exactly the reverse, then that is the negative of lattice energy. This step is actually the negative of, it's the negative of lattice energy. You're breaking the lattice. Forming the lattice from gaseous ions, that's lattice energy. And this step is actually endothermic because you're actually breaking bonds. Now, as soon as when you're vigorously stirring, the lattice breaks, what immediately happens is कि वो जाते हैं and they get surrounded by water molecules. So that step is that the gaseous ions are now turning into aqueous ions because they're now getting attracted to water molecules. So bond formation is happening. This is enthalpy change of hydration. So gaseous ions, immediately after bond breaking, they turn into aqueous ions. Okay, and since bond formation is happening, this step is actually exothermic. Okay, now that's basically your Hess cycle. It's your Hess cycle. You've got an endothermic part. Okay, so there's this endothermic part, and then there's this exothermic part. ठीक है, dissolving an ionic solid, break the lattice, ठीक है, break the ionic bonds, you get gaseous ions, separate ions, immediately they get surrounded by water molecules, so that's enthalpy change of hydration, where bonds are formed. The ion and the dipole on the water molecules, they get attracted to each other, and that's the exothermic part. Okay, so that's one path being equal to the other path, so enthalpy of solution is basically equal to the other path. ठीक है, ये clear है? Is this cycle clear? सारों clear है? अहमद clear है? साथ
Yes.
मैं ठीक है.
Yes.
Okay, so that's basically our hair cycle for this one. And we can write the expression that enthalpy change of solution is basically equal to what? Breaking the lattice, just the negative of lattice energy, plus then the ions forming bonds with water, that's enthalpy change of hydration. And we get this relationship, and this will be used to solve, I mean, just like your normal hair cycle, you'll know two things, you'll be able to figure out the third thing. इसके अंदर ये कि the negative of lattice energy, this part is actually the endothermic part. Forget the negative sign, that's just by definition negative because you're going in the opposite direction. You're breaking the lattice and then you're forming bonds with water, so that's bond formation, that's the exothermic part. Now, whether the overall enthalpy change of solution, now this is important, whether the overall enthalpy of solution comes out to be exothermic or whether it comes out to be endothermic, वो सब कुछ ना depend करता है which one is the bigger one. ठीक है, so imagine you're trying to dissolve a substance. If the lattice is like really weak, you've got a very weak lattice, ठीक है, तो मुझे बताओ कि would it dissolve easily or would it be difficult to dissolve? क्या होगा if you have a very weak lattice? पानी में मिक्स हो
It
जाएगा,
will dissolve easily.
easily होगा, ठीक, हाँ easily होगा, ठीक है, like table salt, ठीक है, NaCl, that's got a very weak lattice, and relatively speaking it probably forms very strong bonds with water, it's very attracted to water molecules, so in that case ये वाली value कम हो और ये वाली value ज़्यादा हो, ठीक है, like breaking the lattice is easy, and you stir with a spoon and all of a sudden with very little energy the entire lattice breaks down and then it attracts water molecules very, very strongly, so the exothermic part is bigger. So if this is small and if this is big, then that means the substance is going to be very soluble. ठीक है, ये indicate करेगा कि the substance is more likely to dissolve very, very easily. Vice versa, if you've got a very strong lattice, ठीक है, marble dissolve नहीं होता, ठीक है, marble is calcium carbonate, it's an ionic compound, very hard to dissolve. So why? Because probably its lattice is very strong, so that means the lattice energy, the amount of energy required to break the lattice, that's very big. And simultaneously, if it doesn't really attract water molecules, even if you're able to form bonds, even if you're able to break the lattice, the ions don't attract water that much. If this is small, it's not very exothermic, the attraction is not very strong, even in that case it's not going to dissolve. So if this is big, and this one is small. तो इसका मतलब it's not going to be soluble. ठीक है, ये रूल पता लग गया कि when is an ionic compound going to be soluble, when it's not going to be soluble. Is that clear? Clear है?
Yes.
अच्छा, अब इससे आगे ये कि अच्छा, next part is कि इसके ऊपर there'll be two questions. One will be math related. The other one, you have to do the calculations. ठीक है? The other one would be based on it's going to be based on it's related to group 2 actually. ठीक है? But it's going to involve the same cycle. So we're going to do the group 2 part over here. So based on the same exact cycle, ठीक है, you have to justify two things qualitatively, ठीक है, without any numbers, without any calculations. You have to describe. ये question होगा. Why does the solubility of hydroxides increase down the group? So why does solubility of increase down the group? So you'll be asked to explain this using the cycle that's given above. ठीक है, तो इसमें होता है कि if you look at hydroxides, magnesium hydroxide is not soluble. Or you can say, well, not soluble is not correct. It is slightly soluble. You can say that it's very slightly soluble and almost negligible. It's got a pH of 8. थोड़े बहुत minute quantity of OH ions are going to be produced. Then you have got calcium hydroxide down the group. That is slightly soluble, or you can say partially soluble. Iska pH hoga na, that's going to be around 10. And then you've got the bottom two, they're very soluble. Strontium hydroxide and barium hydroxide is even more soluble. So these two are very soluble. So their pH is going to be 12 to 14. Acha, khair, explain karna. You have to explain why is that happening? Why is the solubility increasing? And we're going to use the same cycle that we just drew over here. So explanation yogi, I'm going to draw one for let's say magnesium hydroxide. So if I want to dissolve magnesium hydroxide, which is a solid, I'll mix it in water and it will turn into aqueous solution. So it's going to become Mg plus 2 aqueous, and it's going to become 2OH minus 1 aqueous. Now this is not very soluble. So iska kya matlab hai? What is the enthalpy of solution? Is it endothermic or exothermic?
Endothermic.
Okay, so it's endothermic, right? I mean, it requires energy to dissolve it. It does not dissolve on its own. So one trend is that when you go down the group, right, basically your delta H solution is becoming less endothermic or more exothermic. Or vice versa, you can say it becomes more exothermic. Okay, that's why it's becoming more soluble. So anyways, right now, this enthalpy change of solution is It's more endothermic. And then you have the Hess cycle, which is you're going to break the lattice, so it's going to turn into Mg plus 2. First step, break the lattice, scatter the ions. So it's going to form 2 OH ions gaseous. Or जैसे वो बनेंगे ना, so it will get surrounded by water molecules. So it's going, I mean, they're going to get hydrated. So you break the lattice. That's your endothermic part. And then you form bonds with water molecules. So that's your enthalpy change of hydration. That's your exothermic part. अच्छा, अब ये थोड़ा सा confusing होगा कि, I mean, it's not confusing. It's just you get a very typical question on this. So you now have to explain, based on this diagram, why the enthalpy solution is becoming less endothermic down the group. Achha, so what happens, first step, what happens down the group? Okay, when you go down the group from magnesium hydroxide to barium hydroxide, so when you go down the group, I mean, whether it's barium hydroxide or whether it's magnesium hydroxide, the Hess cycle is exactly the same. The only difference is that the cation is different. Okay, the OH ions are still there. बस वो होगा कि magnesium ions की जगह you've got calcium ions, or you've got strontium, or you've got barium. So down the group, your cation changes. So what happens is that the ionic radius increases, which means that you've got bigger ions. तो bigger ions का क्या होता है? Bonds weak होते हैं. Bigger ions, remember, they form weak bonds. ठीक है, we did discuss वो lattice strength हमने discuss की थी. So remember, bigger ions, they always form weak bonds. So if you've got bigger ions, यहाँ पे barium होता है ना, you got bigger ions. Bigger ions have a weak lattice. So the lattice energy would decrease. It would be easier to break the bonds. But at the same time, bigger ions are not going to form very strong bonds with water as well. तो ये भी कम हो जाएगा, ठीक है? It's not going to form very strong bonds, so the enthalpy of hydration is not going to be that exothermic, ठीक है? So ये बात clear है? Is this clear कि what happens down the group, that the cationic radius increases? तो ये भी decrease करेगा, ये, ठीक है? ये clear है?
Yes, sir. Yes.
Yes, sir.
अच्छा, so both, अच्छा अब होगा कि so both lattice energy and your delta H hydration, they both decrease down the group. लेकिन अब हो क्या रहा है कि it's becoming more soluble, right? It's becoming more exothermic, right? तो इनमें से ज्यादा कौन decrease कर रहा है? I mean, both of them are decreasing down the group, but the endothermic part is decreasing more. Exothermic part is relatively bigger in size, ठीक है? वो हमने ये discuss किया था ना कि ये ऊपर हमने ये discuss किया था ना कि if this is small and this is big, then it's going to be soluble. So this is what's happening down the group. This is actually becoming more smaller. It's decreasing a lot more. And dissolving the lattice, breaking the lattice is becoming a lot easier to get down the group. इसलिए वो ज़्यादा dissolve कर रहा है. So the final statement that you just have to write to explain this is, but lattice energy decreases more. यानी उसको lattice तोड़ना जो है ना, breaking the lattice, that's a lot easier now, which is why it's dissolving more. So lattice energy decreases more compared to delta H hydration. Hence, overall, your delta H solution becomes more exothermic down the group. Or you can say less endothermic. Is this clear, this one?
Yes, sir.
Yes. Yes.
अच्छा, बस इसमें issue ये, I mean, this part ना कि the only issue is that it could get confusing in the paper, ठीक है? To just, I mean, it's a very typical question. It's a typical 3-4 mark question. That comes in almost every paper. हमेशा पूछता है कि what happens down the group? Hydroxides, why do they become more soluble? You just have to write this answer. That's it. ठीक है. But उस time पे ना people just get confused with this statement. At least the end part. कि कौन सा ज्यादा decrease हो रहा है, which one is decreasing less or which one is decreasing more. So you just have to be careful about this. Otherwise रट्टे से भी काम चल जाता है. ठीक है. वो एक ही क्वेश्चन आता है बार बार. And there's this opposite question which is exactly the same as this one. This is for hydroxides. Sulfates का उल्टा होता है. ठीक है. For sulfates you have exactly the same question. In that question it states that why does the solubility of sulfate decrease down the group? So the last part, the solubility was increasing. Now it's for sulfates, it's decreasing. So सब कुछ same होगा. The answer would be exactly the same, except you're going to change the last part because it's becoming less soluble. उस केस में ना बस ये end वाला part जो है ना, that's going to be changed. इसको देख लेते हैं कि एक मैं बना भी देता हूँ. लिख भी देता हूँ कि you've got MgSO4. That is soluble, very soluble. You've got CSO4, partially soluble. And then the last two are almost insoluble. Well, barium sulfate is very insoluble. अच्छा ये सारा है. अच्छा अब इसका क्या लिखना है कि I mean same thing. ठीक है, I'm just going to write the answer. ठीक है, so your sulfates are going to have exactly the same. ये OH की जगह ना, the only thing is instead of the OH ions you'll have sulfate ions. That's the only. Otherwise the cycle is going to. बल्कि I'll write down the cycle. If I have MgSO4 solid, I'm going to dissolve it, aqueous, and it will dissociate into aqueous ions. So it's going to turn into Mg2 plus aqueous. और क्या होगा SO4 minus 2 aqueous. So this is enthalpy change of solution. इसमें steps क्या involve होंगे? Break the lattice. Stir करोगे vigorously, it's going to turn into gaseous ions. So you're going to have sulfate ions. And then you're going to hydrate it. ठीक है, so ये enthalpy change of hydration है. They're going to get completely surrounded by water molecules. This is the negative of lattice energy. This is your endothermic part, and that over there is your exothermic part. ठीक है, बाकी जो है वो exactly same statement. So the statement is going to start with, I mean, the question is going to be exactly the same. So what's going to happen down the group? Cationic radius increases. So what happens because of that? If cationic radius increases, so what happens? Both the lattice energy and enthalpy change of hydration decrease. Down the group. लेकिन कौन सा decrease करेगा? It's becoming insoluble. So since it's becoming insoluble, so that means the endothermic part, breaking the lattice down the group, is relatively difficult. So lattice energy क्योंकि down the group it's becoming insoluble, so that means breaking the lattice down the group is still relatively difficult. So but lattice energy decreases less. still harder to actually break the lattice. While enthalpy of hydration or the attraction for water molecules, it decreases more. Hence, delta H solution becomes more endothermic overall down the group, or less exo down the group. Okay, is this clear? ये clear है?
Yes, sir.
Yes.
अच्छा, लेकिन दोनों questions की ना recommendation है कि you just memorize this, ठीक है? Because both of them are kind of explaining the solubility of hydroxides down the group, explaining the solubility of sulfates down the group. They're very similar, but the statements are actually kind of opposite to each other. So people, when they write answers for this, they usually mess this up, ठीक है?
Sir,
Yes.
is it the same for carbonates as well?
The carbonates are all insoluble. तो उसके अंदर तो कोई ट्रेंड ही उसके अंदर तो कोई ट्रेंड ही नहीं है ना, so you don't have to justify anything. अच्छा, हाँ, इसमें था सल्फेट्स में the trend is opposite. They're becoming less soluble down the group. Hydroxides, they're actually becoming more soluble down the group. So the trend is exactly the opposite. So the rest is just the other question that you're going to get is you'll be given values and you'll be asked to find out or calculate. Latino में से ना, you might be given two things. You'll be asked to figure out the third thing. That's it. So we'll just jump to questions now. As a first part, 4-mark question, ठीक है? Remember, paper बड़ा है, तो उसमें ना they ask, I mean, you get asked everything, ठीक है? Everything that you study almost gets asked in that paper, ठीक है? Because it's a big paper. Now, describe and explain the variation in the solubility of the hydroxides of group 2 elements. Louis question 4-mark, ठीक है? So what you're going to write is that down the group, वो लिख लेते हैं, एक दफा लिख लेते हैं, बाकी फिर होते हैं. So down the group, what happens? Cat ionic radii increase for the cations, and so both delta H lattice energy and delta H hydration, they decrease. But hydroxide, so they become more soluble down the group. So that means breaking the lattice is easier. So, but lattice energy, delta H Le decreases more, easier to dissolve down the group. Compared to delta H solution, delta H hydration, sorry. Hence, overall, your delta H solution becomes more exothermic down the group. अच्छा, ये तो उसका typical answer आ गया, ठीक है? अच्छा, now we're gonna try and do the rest of the question, which is इसमें मैं देख लूं कि is it related to, let me find a hydration question first. Baki generic questions when are related to AS. We're going to do that. Let's do this quickly. Electron affinity, the tendency to gain electrons. नहीं पहले वो hydration वाला question. Let me just find that out. ये भी simple है. हाँ ये वाला आ गया ठीक है enthalpy of solution. So let's try and do this one. The first one, what is meant by the term enthalpy change of hydration? So it's what? It's gaseous ions turning into, it's the energy that is going to be released when अच्छा साथ बस खत्म करेंगे बस मैं ये क्वेश्चन करके ना कल का डाउटफुल है क्लास का तो आई जस्ट फिनिश दिस ठीक है रिकॉर्डिंग्स में सारों की ना शेयर कर दूंगा लास्ट क्लासेस की अच्छा लेट्स कंप्लीट दिस क्वेश्चन दिस क्लास ठीक है energy released when what happens when 1 mole of gaseous ions are completely surrounded by water molecules to form 1 mole of aqueous ions. So write an equation to represent the enthalpy of hydration of magnesium ions. So magnesium ions are what gases. Pani mein dala, they're going to turn into aqueous ions. That's it. Achha, suggest why the enthalpy of hydration of magnesium ions are is greater because it's a smaller ion. Smaller ions, remember, smaller ions are going to attract more. They've got greater charge density. ठीक है, हमेशा smaller ions are going to form stronger bonds. So smaller ions have greater charge density, so there's going to be more attraction for water molecules. और ये उसमें भी लिखा हुआ है कि oxide ion. Why don't you have enthalpy of hydration of oxide ions? Because they don't get surrounded by water molecules. Instead, they actually react with water molecules. So इसलिए ना you don't actually have an enthalpy of hydration of oxide ions. ठीक है? ये clear है?
Yes.
So this one is that he's saying, so we're going to do paper 5 related experimental stuff. We're going to do that later, but it's a simple question. He's saying that enthalpy change of solution of MgCl2 is represented by the following equation. Describe the simple apparatus you could use and the measurements you would make in order to determine the value of enthalpy of solution. So what is enthalpy of solution? Just take MgCl2, just take water in a beaker, put MgCl2 in it and dissolve it. And use a thermometer to figure out what amount of energy is released or absorbed. So that's it. Okay, you just have to figure out. You need the initial temperature. So basically, you need to calculate delta T. You can figure out the energy that is released or absorbed by using Q is equal to minus MC delta T. That's it. And or can I say you need the mass of MgCl2 because you're going to then use that to calculate moles. Okay, enthalpy of solution is for 1 mole. So that's it. You just figure out कि MgCl2 को पानी में डाला, dissolve किया. What do you get? How much energy is produced? That's it. Is this clear as well?
Yes.
Yes.
Yes, sir.
Or you can just label it. You need a thermometer, you need a beaker, and you need maybe a measuring cylinder to measure the volume of water. Okay, the mass of water होगा ना. So maybe there's 100 cm cube water. So you can measure that using anything. Sorry. Heat loss prevent करने के लिए we're going to do the experimental stuff later. Instead of a beaker, use a styrofoam cup probably. ठीक है? But that comes later. We'll discuss experimental techniques later. यहाँ पे आ जाते हैं. Now he's saying by constructing relevant thermocycles, use the above data to calculate a value for enthalpy of solution. So what is the enthalpy change of solution? It's 1 mole of MgCl2 solid dissolves and turns into or dissociates into aqueous ions. Now remember, aqueous ions can be written as MgCl2 aqueous as well. अच्छा ये वो बड़ी trick play करते हैं, ठीक है? Remember this that remember this always that NaCl aqueous can be written as Na plus 1 aqueous plus Cl minus 1 aqueous. Both of them, they are exactly the same thing. ठीक है? They're exactly identical things. ठीक है? ये questions का ना बड़ा matter करेगा because sometimes they give you NaCl aqueous, sometimes they give you Na plus 1 and Cl minus 1 aqueous. It's exactly the same thing. So anyways, यहाँ पे ना you've got MgCl2 solid and it dissolves, it turns into MgCl2 aqueous. That's the enthalpy change of solution. अब ये वाला part जो है ना, that's an AS part, AS question, which is that AS question क्या था कि you've got the enthalpy of solution of enthalpy of formation of MgCl2 solid. This is minus 641. And you have the enthalpy of formation of MgCl2 aqueous as well. That is minus 801. तो मुझे था वो कौन सा formula था which was कि if you know the enthalpy of formation of the products and you know the enthalpy of formation of the reactants, how can you find the enthalpy of that particular reaction? ये कौन सा formula होता था?
Products minus reactions, reactants.
Okay, so there was a formula related to Hess cycle, which is that the enthalpy of any reaction is basically the enthalpy of formations of the product minus the enthalpy of formation of the reactant. Okay, that's related to S. So all you have to do over here is that it's minus 801, that's your product, minus your reactant, that's minus 641. ये minus minus जो होगा वो plus हो जाएगा. So what do you get?
Minus 160.
So we're getting minus 160 ठीक है, kilojoules per mole. So we got this. Now in the next part, he is now asking us to figure out the enthalpy change of hydration of Cl ions. Since I have the solution enthalpy change, so now I'm going to construct वो solution वाली Hess cycle, MgCl2 solid plus aqueous. What is formed? MgCl2 aqueous, which can also be written as Mg2 plus aqueous plus 2Cl minus 1 aqueous. अच्छा इसकी वैल्यू मुझे पता है, it's minus 160 now. ठीक है, I just figured out in the previous part. इसकी cycle क्या थी? I would first break the lattice, which is I'm going to get gaseous ions. And then I'm going to form or hydrate them. ठीक है? So I need to break the lattice. ठीक है? The lattice energy is provided. It's minus 2526. That's given in the table above. So this value is given. That's minus 2526. You break the lattice. लेकिन ये plus होगा क्योंकि it's the negative of lattice energy. And once you have gaseous ions, you hydrate them. So the hydration of magnesium ion is given. That's minus 1890. ठीक है? That's given. So magnesium ions minus 1890. That's given. Cl ions find out करना है. I don't know what Cl ions is, so that's x. So it's going to be minus 2x क्योंकि I'm hydrating. बल्कि इसको प्लस ही लिखो क्योंकि वो x का साइन खुद ही नेगेटिव होगा. ठीक है? So we're going to take it as x and multiply it by 2 because you got 2 Cl ions. ठीक है? ये मेरी Hess cycle complete हो गई है कि MgCl2 dissolving minus 160. The enthalpy of solution was found in the previous part. And once I have that, breaking the lattice, that's given in the table. Hydrating the ions, Mg ions की hydration, that's given. Cl ions, I've taken that as x. There are 2 of them, so I just took it as 2x. That is not given. So that means, तो यहाँ से क्या पता लगेगा? It's going to be that minus 160 is basically equal to what? One path is equal to the other path, so it's equal to 2526 minus 1890 and plus 2x. ठीक है, ये clear है question?
Yes, sir.
Answer बता दो बस इसका क्या है? What's the answer?
Sir, negative 398.
कितना है? Negative
398.
398. डबल चेक कर लेना इसको. Negative 398. ठीक है, सो ये इसके ऊपर ना वो एक क्वेश्चन भी हो गया. ठीक है, जस्ट रिमेम्बर आपके पास you just have two cycles. One is this one. The other one is the Born-Haber cycle. ठीक है, that's it. बाकी सब कुछ वही पुराना. That's the AS stuff. ये खत्म हो गया. Energetics is done. ठीक है, energetics में entropy is left, which is got nothing to do with energetics actually. तो वो फिर next time करेंगे, लेकिन we'll just do some more questions later on. ठीक है, अभी रहते हैं इसमें energetics में ना we've got entropy left. ठीक है, लेकिन ये heat वाला, enthalpy change वाला, everything is done. चलिए ठीक है, ये फिर कल का मैं बता देता हूँ. ठीक है, whether we going to have class tomorrow or not. ठीक है, वो I'll just message tomorrow then. चलिए, कोई question नहीं है?
No questions, sir.
Okay everyone.
Thank you, sir. Allah Hafiz.
Take care. Allah Hafiz.